Hello, it's David. Back to the STFM today, as this is one of my incidental ongoing series about updating the boards, and this is a crucial one. Previously you've seen me make my new PSU, over here, new power supply. I've got my new OS ROM here. Obviously you've seen in the past the DSTB1 booster here, which plugs into the 68,000 socket, which you've seen me replace. And I've got my Gotek in over here. Now, I've not put that in today because I just want to do some testing with the plain board. So we've just got the 68,000 in, and it's running happily. The keyboard's off to one side, just as a bit of a space saving exercise. And you can see there we are, we've just run gem bents all the way through. The reason why the figures aren't 100% is because this is using this is the Emutos AES and the VDI rather than the original TOS 1.04 ones, and also I was running in mono mode there, 2 color mode instead of 4, so that makes a difference to the statistics. But all of the numbers that count, the integer division, the ROM and the RAM access, are 100%. So this is working perfectly. But these machines are getting on a bit, and there's normally one or two things wrong with them. So what I intend to address today is one of what over on the Exxos Forum are called the mandatory fixes. The easiest way to find the Exxos Forum's mandatory fixes is to type that literally into Google, and you'll see that it's the first hit you get. Now, there's 12 listed here at the moment, but that may increase. And these are fixes suggested to the different machines to improve their stability. We're looking at the last one here today, the bus resistors. Click on the link for any of these issues and it'll take you to a thread that explains each one in full detail. So there are two primary buses on the 68,000 base machines. The address bus, which is 24 bits, actually it's 23, one is inferred, and the data bus, which is 16 bits. Now each one of those is a line on the board which links between all of the different parts. So there'll be a link between, let's put that into continuity mode. So there'll be a link between this pin at the top here, which I believe is D4, the fourth or the fifth data line pin, and somewhere here on the ROM, for example. There we go. So these go all across the board, and they're subject to quite rapid changes of level. They have to go from ground to off to on, basically, which is ground to 5 volts, very rapidly. This is an 8 megahertz machine, so it's all relative. But in this case, within a clock cycle is going to be about 100, well, half a clock cycle, so it'll be about 62 nanoseconds, up and down, up and down, up and down. And if you've got something driving it over here and you're listening for it over here, or well, vice versa, there's the chip. So over here we've got the Yamaha sound chip. If we've got that doing something, or that listening, and the processor here driving, that's a long way for that line to stretch, and you're going to get ringing and bouncing and basically noise on your line. So the way you work around this when you're designing the boards, and this is not anything to do with retro hardware, this is still in common practice today, is you apply pull-up resistors. So all of those data and address lines will be at some point have a resistor which between them and normally you pull up, so them and the 5 volt line, which will bias them high. So if you don't drive them, they end up high. They don't end in a sort of like unstable condition. And also it helps dampen down any sort of oscillations that you might see during long transfers like this. Now on these boards, they are normally 10 kilo ohms. So if I were to measure the potential there between that D5 pin and our positive 5 rail. There we go, 9.94 kilo-ohms. So it's a 10k resistor. Now down here I believe this is the address line 4 pin, I think. Is that address line 4? Address line 5. Okay, so it's data 4 there and address 5 down here. And if we measure the same thing, 10 kilo-ohms. Now that's fairly standard, to be honest, for these old machines, but as materials, as components degrade, as the boards themselves get older, and certainly if you start adding in new features like the fast ROM or my booster DSTB card here, for example, it's really at the lower limit. When I say lower, I mean higher in terms of resistance, the lower limit of what is feasible or what is realistic in trying to stabilize those oscillations. So on my DSTB1 board, for example, you can see that there are positions on the board here for resistor packs. So there's resistor, I think that's 10, resistor pack 10, 9, 8, 7, 6, around there, another one down in the corner here, which are not populated on this board. I've only got one on the board, which is actually doing a vital role. Those are optional on this board, and those are in case you don't have the mandatory fixes done on the motherboard itself. That will basically do that for you. Now, I haven't populated on that because on my STE, on which I developed this this project, the mandatory fixes have been done. Again, it's on an add-on board, but they're in place. On this board, this STFM board that I purchased off eBay specifically for testing my hardware on, I have not done them yet. So this is today's task. So the resistor networks in question, there's RP2 over here, these are the red ones, RP3 down here, RP8 here, RP4 down here, and RP, I think that's 6 up here. Those are the networks in question. Now, the recommended way to do this is that you desolder all of these and you replace them with approximately 2.2 kilo-ohm resistance packs. Now, the way these work is that one end is tied, so they're common bus. So one end will be tied, probably that end, looking at it, will be tied to 5 volts, and the others, so that there'll be 9 pins, so the other 8 pins will all have a 10 kilo-ohm resistance between that pin and wherever they're going. So that's how the pull-up happens. So that's probably, I would imagine, I haven't checked, probably that's half the data bus, that's probably the other half the data bus, and then these 3 are likely the 3 address bus blocks, because that's obviously 23 lines. My plan is to do something different though. I'm a coward. I'm not great at desoldering, even though I've got my fancy new desoldering station from this video up here. So what I intend to do instead is to flip the board over and add extra resistance underneath, extra resistors underneath. So these resistors here, this is a 3K3 bust resistor. So exactly the same format as this, exactly the same package. It's 2.54 millimeter pitch and 8 or 9 pins with 1 common bus. 3K3 means that when you combine 3K3 resistor and a 10K resistor, you get about a 2.5 K net resistance, which is close enough to the recommended 2.2 that I will consider that fixed. So let's flip this board over, take the shield off, and see if we can do that. Okay, so here we are on the bottom side of the board, and I've just marked the resistor packs in question with a bit of pencil here so that I can see what's going on. But looking at them, they don't look in the greatest of nick. This is dull as ditch water over here. You can see there's the VCC connection, so that's the round, that's the square pad, and then the round ones here are obviously all the different. I'm not sure if they are address or data. I'd guess that they are address over on this side, but they look awful, to be honest. So I think we need to clean them up and reflow them anyway. There's another one just over here, which looks a little bit better, but again is not really terrific. The next one is up here, and yeah, that's the. I think that's the was that the MFP that's been replaced above it, but that doesn't look special either. We might have a trouble with that one because that one looks like it's going to be difficult to fit in, but we'll have a play with that. Then over on this side, this one actually doesn't look too terrible. It's probably the best of the bunch, and will probably also be the easiest one to work with. And this one is, I think, possibly the worst of them all. Look at the state of this. This is crusty. I don't know what's going on with this. We may actually have to resort to desoldering that one. That one looks really. It's not coming. It's not coming across on the video quite as bad as it looks in real life. That does look quite simply shabby. It looks like it's got bits crap growing off it, and I don't know. That's awful. Right, anyway, so I mean, we're going to give them a jolly good reflowing, and we see where we get to. Let me give you some news from this channel sponsor, PCBWay. A year ago, PCBWay moved into a new factory, and now they've had time to get their feet under the table, they're able to offer some substantial price reductions. There's up to 20% off 4 and 6 layer boards, bulk order prices are down, and 5x5mm track width and 1/4mm minimum hole size designs will also see huge discounts. The event started on the 5th of August 2022, and you need do nothing special to obtain it. Why not log in now and see if your design, manufactured to PCBWay's normal quality specs, is much cheaper than you thought all of a sudden. And if you're there, maybe take a look at their CNC machining, sheet metal fabrication, 3D printing and injection moulding services whilst you're at it. See the links at the bottom of this video for more information. Okay, so we're going to start on this one down here, which is resistor pack 4. So it's probably the easiest one to work with. Just try not to damage any of these traces. And what I'm going to do is to try and solder this on. It's actually going to be that way around. We'll try and solder it on something like that, and lay it flat, and hopefully that will work. I'll probably just do one and then flip it over and try it again in the shield to make sure it doesn't stand off too far. So the way these work, I don't know if I might be zoomed in too far there. There we go. So one side has has writing on it, but has a dot. Do you see this? It's quite faint actually. That is pin 1. That is the common terminal. So the common terminal on here appears to be, yep. Don't know if you can make it out. Yeah, you should be able to. That is the square terminal. So that's in our case the 5 volts line. So we will we'll try and get this in here. Should I go something like that? Maybe that might make it more flush, but I kind of want them to touch the base where the actual solder is going to be, where the pad is. I think I might have to get in and anchor one end like that, and then come at it. So let's get some flux on that end there. Introduce some new solder. I've got the through hole tip again. I haven't done any soldering for feels like months. Massively out of practice. What could possibly go wrong? There we go. So an enormous load of solder there, an absolute bucket full of solder. And we'll try to introduce our pack. Nope. Okay, that's one end. So I'm going to try the same at the other end and then see whether we can fold it flat. So I'm pushing this in as much as I can so that as many of these pins touch the other solder joints, which should then make it easier for me to go along and join them up. Which is what I'll now try and do without desoldering the ones next to them. I know this isn't going to be the prettiest job in the world. I just hope it's going to be strong enough without interfering with the operation of the board, or how far it sits in the in its case. Okay, so before we go any further there, what I'm going to do is to test which lines these actually are. So I'm in continuity mode here, and just going from this pin here okay, so that's just trying to picture this in my head. There's dust there, might clean it up a bit more. So that, I believe, is on the data bus. Yep, that makes sense. I think that's the data bus end. That's the address bus end. No, actually, that's the address bus end, I think. Okay, so we're on the address bus. That's fine. So let's then quickly check the new resistance between our data line here and VCC. So this one on the end. That's showing 5 kilo-ohms to that line. I can't remember which line it was. Well, first of all, let's just go to the 5 volts line, which is, I think, here. So we're showing 1.2 kilo-ohms now. That's showing 2.5. Oh. What was I measuring? That was odd. Maybe I must have been bridging the two. There we go. So 2.5, and actually, if these are the lines over here, we can measure it to the CPU. If I'm getting a decent connection. 2.5-ish or 2.4-ish. So given that the target, that one's still 10k, so that's one that we haven't done. That one's 10k, that's one that we haven't done. That one's 2.5. There we go. So given the target was to try and get to 2.2, I'd say we're on track with that. So now I need to just gently try and bend this down and see whether we can get this flat enough to get back into the shielding. So this is the angle that has resulted after that work, and you can see it sticks up quite a long way from the motherboard. So I'm just going to try now gently bending those pins and hoping, well, we'll find out if the solder breaks, then we'll have to pre-bend the next one, but hopefully it's the pins that are going to bend here. There we go, and we've pushed that down flat. So what we now need to see is whether that will fit as it is back in the shielding. The shielding itself has this what feels like cardboard insulation layer along here, which obviously is designed to stop all of the exposed pins that we saw on the back there shorting out against the shielding. So the question is, as we look along the board like that, is that sticking out too far? for this to work. Now I'm not the best at getting these in and out anyway, and I can see just there's RP4, that's the one that we're working on, and that particular metal tab is impeding me, so that's an irony, because that's the one what I would expect to have problems with, or the area I should say. Now this one is, yeah. Right, well, I'll try and show you this. There we go. Look, that's slotting in. You can see the lip there if we concentrate on this area here. You can see the height. Well, you can see the board itself, and there's RP4 right next to it, and that appears to be all the way down to me. So I think certainly in the case of, well, that resistor pack, everything's fine. I'm tempted just to reconnect things and make sure the machine still boots with one of its, did we decide it was a data line? I think we did. One of its data lines still, no, that's an address line, isn't it? I think that's an address line. That's coming from there. Yeah. So one of its data, address line blocks pulled up to 2.2. Now, because I'm naturally pessimistic, I've decided to whack in the power supply and connect up the monitor again, and just make sure that we still have a booting machine after one of the or 1/3 of the address lines have had the 2.2 pull-up applied. If it doesn't, we know we've got a problem. If it does, great, we'll continue with the rest of the lines. So everything connected up okay here. Let's have a look at the monitor. And let's throw the switch. Got a green light on the keyboard, got a green light on the monitor, MUTOS boots up. There we go, and there's no disk drives, so that's to be expected. On we go. Okay, that was surprisingly painful. So I'm just going to get the ohm meter out again on that one because I did not enjoy that. That was not as much fun as the last one. The the pads were a lot more crusty, and I probably ought to. I think I'm going to take a different approach next time. I might get a finer tip in there. So let's have a look which lines were these. So I'm going to go from, that looks like 5 volts there. So that should be 0. Yep. Okay, and let's test some of these points here. 2.5. 2.5, 2.5, 2.5, 2.5, 4 and a bit, maybe that's not one of mine, 2.5, okay. this might be an issue actually. This potentially is actually impinging upon the place where the case sits. If that's the case, I'm going to have to revisit that one and flip it over. But as before, I'm just going to check a few connections out. Now this one's slightly unusual in that the pin 1 is actually bent over. Which is going to make soldering to that one a bit more awkward, but I suppose what I'll just have to do is to solder to the side of it instead, which I think is eminently doable. In fact, given the positioning of this chip here, it might make sense to solder to the side of all of them actually, so I'll straighten that pin 1 back out, because that will fit in there really quite nicely if I can get that solder flowing. Just one left to do. This one is, I think, the worst of the bunch, so we'll just go straight in with the heavy duty flux. Try to add a lot more solder without shorting to that pin there. Just firstly checking for shorts, and then we're going to check if we have continuity between each pin and somewhere on the 68K. This pin here, this is the one that looks dodgy. Yep, so that's got connection to, I think that must be A5, 6, 7, 8. I'm guessing that's A8. So that pin is A8, but our resistor nope, it's floating. Okay, let's get back in there again. Don't seem to be able to heat the pin well enough. Maybe that got it there. No, it certainly doesn't seem to be flowing. Okay, that's ugly, but I'm pretty sure that's now made a connection. Yeah, again, as soon as I wipe off the flux, it doesn't flow. Got some Loctite solder here. It does claim to have flux in it. There is little evidence, however. So this is the 68,000 socket down here, and all I've been doing is just running from the pin of the resistor, and it's important this is the resistor pin, not the one on the motherboard, and looking for connectivity. That's where it changes to that side. There we go. And that's VCC, or somewhere around here, down there. Yep. Is that it? No, that one. There we go. Okay, good. Right. So I think we should be able to do another test with this before we put it all back together. Okay, so out comes the power supply and the monitor cable again, and let's keep an eye on the keyboard power light down there, and we'll throw the switch. Okay, power light goes green. Nothing on the monitor. Okay. All right. Well, it's entirely possible I've shorted a couple of address lines. Let's get. Oh, wait a minute. Is our monitor actually plugged in properly? No, I think it is. Try one more time. Monitor wasn't plugged in. Oh no, there was a little bit of screen corruption there, I think. Did I just see a little bit of screen corruption? Was I dreaming? Okay, so maybe that was my imagination. I thought I saw a bit of screen corruption, but it's entirely possible that that was just dodgy memory from the previous attempt to start up with no monitor connection, because it would have been trying to boot up in colour mode. Right, so I think it's time for a bit of a scrub down, and we'll call that a success. So far so good then, but I don't think we can 100% call it a win until I've checked that we can actually fit these back into the shielding. This one, for example, I'm not sure about. So let's get the shielding back out. Let's see if we can nestle it in, and let's see if we're going to have any trouble with this one over here. I think this one down here should be okay, but we just need to check. On first glance, it all seems fine. We come back to look at the front edge again. This is the one we tested before, and that seems to line up adequately. That one, that's got loads of room. That's springing down happily enough there. Soluble. So the one that I was most concerned about was over here next to the MFP, I think. But that, in fact, you can see it. You can see it underneath here, actually. Is that going to be an issue? There's actually a cutout in the metal shield, and it covers that hole. I don't think that... That's probably a screw hole, isn't it, in the case? Okay, so that might be an issue if I actually had a screw. I don't have a screw. I don't have a case. So that's probably going to be fine, but that's something to bear in mind. Perhaps my choice of orientation for that one was slightly awry. Now, I'm not going to put this back in here permanently because I haven't finished cleaning up. That is really what I need to do next. But what I do want to do is to just check one more time whether she boots up still, because there is, of course, a concern that it might something pressing on the bottom might cause a short, or well, any kind of stress-related failure. So once more, onto the breech. We'll reconnect the power supply. Might as well put the disk drive in and let it do that that memory test again. And our monitor. So it starts to boot okay. Up comes our desktop. And our initial signs are good. So there we go. She fits back in her original shielding. She's got now a nice stable address and data bus, which means me adding expansions in here ought to be a far more reliable issue. Thank you very much for watching. See you in the next video.